Good afternoon. So now we will open the breakout session on science, technology for climate crisis response. So in the first part, I would like to invite Dr. Yoon Won-tae, Secretary General UEA, to give congratulatory remarks. Please welcome Dr. Yoon. Okay.
안녕하십니까. 저는
Good afternoon. My name is Yoon Won-tae. I'm Secretary General of UEA. I would like to thank you for coming to the session on science and technology for climate crisis response. I would like to thank Dr. Kim Kyung-ung from GIST IERI for chairing this session, and also I would like to thank Professor Kim Hyun from University of Minnesota, and also Dr. Kim Chang-hon from Green Energy Institute, and also Professor Yoon Jin-ho from GIST. Thank you. Also, because of the pandemic, we have Hak Mao, Lua Lido, and also Clara Landerino participating online, so thank you. So, according to the REN21 report, 55% of people in the world are living in cities, and they take up 3/4 of the final energy consumption, and as a result, they are emitting 75% of total carbon emissions. And that is why the role of cities are very important in reaching net zero. It is quite fortunate that since the Paris Agreement, 120 nations have declared carbon neutrality, and more nations are discussing carbon neutrality goals for 2050. And in coming up with specific implementation plans and roadmaps to meet that goal, it is very important to have objective data in order to finalize our numbers, and our goals and plans have to be based on science. And if we have policies that are optimized using preemptive development of science and technology, and if we are able to innovate our lifestyles, that will be very important in recovering resilience against climate change and making our cities climate proof. And I believe that converging fourth industrial revolution at the city level and forming a smart city would be a key solution. And this is made up of three things. First is the energy reliance through energy transition, having smart transport, and having a emergency response system against crisis, climate crisis, that is. And by having a smart city, we will be able to protect humans from natural disasters, and we will be able to guarantee sustainability. By forming Smart City Zero, we can achieve net zero, and by doing that, we can become self-reliant in terms of energy and build resilient cities. And we must do our duty to our future generations. And through this forum, I believe that we will be sharing very important scientific technology and policies with other cities. And I believe that this will be a very meaningful session where we talk about cooperating with other cities and talk about the role of cities. So I congratulate you on holding this session, and I hope that it will be a very fruitful session. Thank you.
I forgot introducing myself, but kindly Dr. Yoon introduced me. So I'm the Director of International Environmental Research Institute at Gwangju Institute of Science and Technology in Korea. So my name is Kyung Kim, and I do not have time to introduce our research center, so we prepare our panel over there. So if you have time, you can have a look when you go out. So next, I would like to introduce Mayor of Yeosu City, Mr. Kwon Oh-bong. So he will give a welcome remarks, and we will watch the video message. Okay, please welcome.
Nice to meet you. My name is Kwon Oh-bong. I am mayor of Yeosu in Jeollanam-do province of the ROK. I would like to welcome all of you for coming to the 2021 UEA YEOSU Summit. I am glad to see all of you. Welcome. And I also want to thank everyone joining in through YouTube. We have 50 cities from 20 countries gathered together in order to discuss carbon neutrality in order to create sustainable cities. And the theme of this session is adaptation to climate change and also science and technology. We have to be quite wise as we try to overcome the global crisis, and we must have the strength of science and technology. By realizing carbon neutrality, of course, that is important, and to do that, we need science and technology, and I'm sure that we will be sharing information on advanced science and technology. Yeosu City has declared in April its commitment towards 2050 carbon neutrality. We will be coming up with specific implementation measures and action plans as a city that is in the lead in terms of climate protection. Also, 12 cities and counties in South Sea and South Central region of the ROK are currently bidding to host the COP28 conference in 2023. By doing this, we want to provide a new solution to the current global threat. We look forward to your full support. I want to thank you once again for being with us for the 2021 UEA YEOSU Summit. The discussions that we have in this forum, I hope that it will contribute to creating a city that is sustainable and has achieved carbon neutrality. Thank you.
We will have 5 presentations, so we have 5 very interesting topics from all around the world. But I have special request to the speaker. So as you know, we are behind the schedule. So please finish your talk in 15 minutes. So after 12 minutes, I will give you signs. So hopefully you can summarize. If not, the audience will getting very hungry. So please, understand. Okay, now I would like to invite Dr. Hyun Kim, Associate Professor in University of Minnesota, USA. So he will give an interesting talk about North Korea. Okay, please welcome Dr. Hyun Kim.
Introducing me. My name is Hyun Kim from University of Minnesota, United States. So I'm from public health, and health impact from climate change is one of the important area, but it has been ignored for a long time. So today, instead of introducing some science and technologies on climate change, I would like to share in public health what kind of needs we have from science and technologies. So first of all, I want to start my presentation by introducing this statement, the defining issue for public health during this century. This is from a former WHO Director General, Margaret Chan, Dr. Chen. This means climate change is not a part of public health issue. Climate change can be entire problem of public health, means it can impact our life and any kinds of human health issues. So let me start with some basic science. Although you are familiar with what the climate change is and how that occurs. It is very simple. Basically, climate change is increase of temperature. As you see in the graph, compared to pre-industrial era, it has been increased 1 degree Celsius. With this 1 degree Celsius, you can still feel how climate change can impact our life. Extreme heat every year, longer warm days, and increased storms, floodings. With this 1 degree Celsius, we feel that. But we talk about 2 degrees increase, 3 degree increase, and 4 degrees increase. So our goal is really stop this increasing temperature to 1.5 by 2040. So increasing temperature itself can be a big health hazard, like people die from the heat wave. But it's not that. That's not the story. That's not the end of the story. It also affects the other chain reactions, including this Arctic ice melting. So you're probably familiar with the polar bear. In the North, polar bear, they lose their land because the ice melt and they cannot find the food, so they kill their babies. And so that's not just a TV show. This is a big problem. As you see from the round yellow line, that's from 2000. I think that's 2012. It's not big time ago. It's less than 10 years ago from now. And the ice, they shrink to half. And that goes where? Sea level. So we talk of the sea level rise in Pacific Islands, many low-lying islands, countries, because that really affect their life. Sea level rise, it's not just rising their sea level, but it intrudes into the land and mix with the fresh water. So they lose their drinking water and also their farmland. So no food, no water, then how do they live? So this is one of a picture from the Pacific Islands. In 2030s, that much they lose their land. In 2050. So maybe it's not a big problem for big countries, but it's a big problem for those small island states. So that's why UNFCCC, all the countries, they agree to reduce greenhouse gas to stop this climate change. And this is a projection from IPCC. If we stop using fossil fuel right now, no more greenhouse gas from now, then we can expect 1.5 degrees Celsius increase in 2040. Whatever we stop now, still increase. If we don't do anything, then that's the red line on the top. That's the one, 4 degrees Celsius increase. Maybe we will die, everybody, with the 4 degree. You see the 1 degree still affect our life. So this is a snapshot of how those climate change impact our life. For example, over 35 million people, they were affected by floods, and over 2 million people, they were displaced because of extreme climate events. They lose their job and move to somewhere. And over 1,600 people died from heat waves and wildfire within 1 year. And we will see this number will increase every year now. And mainly we see the four sources of climate change hazard to affect our life. One is the increasing temperature directly affect our health, and extreme weather events, storms, flood, and wildfire, and air quality impacts. Air quality itself is a greenhouse gas, so that's the source of climate change. However, with the increased temperature, that also condense air pollution, that produce more air pollution. So it's like a loop. And then vector-borne disease. we see more malarias, more dengue. And not just the vector-borne disease, but also food-borne disease and waterborne disease every year. So with these 4 main sources of climate change, we see all kinds of health problems. And not just the health issue, also climate change increased people to move because they couldn't find the drinking water anymore. They couldn't eat their local food anymore, so they have to leave. For example, one of the Pacific island, Tuvalu, we actually visited there for our own research for climate change. And they lose their food and water, so a lot of people already moved to New Zealand. So that's another indirect impact of climate change, migration. For example, like forced displacement. They were forced to move somewhere, or planned resettlement. So for the long term, they would try to move somewhere safe, or migration, just move around, no settlement. So this is the numbers from 1 year stat. For example, 272 million people, they migrate in the world in a year. It's a huge population. And 2/3 of those international migrants, they moved to within G20. So luckily, I don't know if it's luck, but Korea doesn't have a neighboring country, so we don't really see refugees or migrants unless they come over the sea by flight or ship. But think about North Korea. If there's huge natural disasters from climate change and produce many refugees, and they will probably go to China or South Korea. And we should be prepared for that. So now I want to introduce about North Korea and their climate change impact. This is not one city, but actually we see many similar countries have big, similar problems. So by introducing North Korea, I think we can learn from North Korea and use for other countries. North Korea has the same problem as South Korea, a lot of air pollution. And more pollution actually because they use low quality coal or many fossil fuels, just wood or anything can easily burn. This is from Pyongyang. And if you see here, this is the satellite image. South Korea has many greens, means many wood. But North Korea almost brown. They use the wood for their fuel. So almost nothing left there. So then what's the problem with this? Without wood, they can be very vulnerable to climate-induced weather, extreme weather events like flood and drought. And this is the temperature over time from 2017, 2018, and 2019. Their temperature increased much more than South Korea because the country doesn't have a capacity to cool down the temperature by removing all the woods. So we know climate change is not a local problem. It's not a single country problem. It's regional and global. Then what is the why some country has a higher risk than other countries? It's the same for probability, climate extreme probability, and magnitude and duration, and exposure, all the same, but difference is vulnerability. So North Korea is much more vulnerable than South Korea. That makes the country in a very high risk than South Korea. This is some official research about the North Korean climate change. They are very vulnerable to climate change due to weak food security. So they are vulnerable to drought, vulnerable to flooding. So that always disrupts their food production. They are also reported as seventh hardest hit by climate-related extreme weather events within 1992 to 2011. And their temperature increase is also higher, as you saw from the map of temperature. Their increase is much faster than other countries. And their projection of the temperature increase is also higher than other countries, and also expect more sea level rise, and 8% decreased surface water for drinking and also farming. So in climate change adaptation, in health sector, we talk about the climate change adaptation more than climate change mitigation. Climate change mitigation is reducing greenhouse gas. Climate change adaptation is how we prepare ourselves from the upcoming climate change hazard. So we talk about the adaptation all the time in the health sector. And the first job is developing policies and action plans. Without policies and action plans, you cannot really do anything. So that's the first step. And interestingly, North Korea has been really cooperative with the UN, United Nations actions. And as you know, in 2015, UNFCCC, they met in the Paris and made agreement to submit nationally determined contributions. Means each country prepared their plan how to reduce greenhouse gas. And this NDC doesn't really, not just about the greenhouse gas reduction, but also how to adapt their country from the climate change hazard. For example, they mentioned in the NDC, environmental protection work should be improved so as to protect and increase the country's resources and keep its air, rivers, and sea completely free from pollution. So they didn't mention anything about the health in the NDC. However, free from pollution, that's fundamental prevention of environmental health problems.
3 minutes.
Okay. Okay, this is a snapshot of the NDC submitted to UN FCCC. And those are specific measures. So they already developed the policies and action plans what to do. And let me just introduce some of them. So they want to strengthen research capacity and climate information service and observation network, and education curriculum for negative impact of climate change and adaptation options, and capacity building for community-based disaster management systems, early warning system, and hygienic and anti-epidemic work, and medical services related to climate-sensitive disease, so hot weather related, and establishment of database for various infectious disease and sustainable monitoring system. So these are the points scientists can help. So they already have this component in their policy and action plan. So our scientists, engineers can help with them by introducing the appropriate technologies and sciences. So that's my message, how to support North Korea's climate change and health as an expert of science. Not just in North Korea, actually everywhere. A similar problem with North Korea. Thank you.
Okay, thank you, Dr. Kim. So thank you for your nice introduction of our session. So we do not have enough time for Q&A. So if you have any question, you can send question by Zoom message, then we can reply later. So now we can change our topic to green energy. So I would like to invite Dr. Chang-Hoon Kim at Green Energy Institute in Korea. So his topic will be technical strategies for expansion of renewable energy supply against the climate crisis. Please welcome Dr. Kim. Okay.
Thank you, Mr. Chairman, for introducing kindly. I'm from Green Energy Institute, Korea. My name is Chang-Hoon Kim, and It is very great honor to be here to talk about my research items, which are those are. I'm going to show you two strategies for expansion of renewable energy supply for our nations. Topics are mainly two topics. The first one is renewable management system and agro PV system. I'm not the specialist for the carbon neutrality, but I looked up many sources from the Google. I found that most of the leading countries made their agreement to carbon neutrality problem until 2050. That is very challenging goal, I know, because most of the countries have many problems to make carbon situations, but especially in China, they have so many secondary industries. So until 2060, I think that's still the challenging goal, but this is very nice to make an appointment to together globally. So in South Korea, we have turning point for the renewables. I see that the paradigms. The first thing is electricity supply basic plant. We made a plan to cover the renewable energy by 20% of our country until 2030. So we so-called renewable energy 3020. And we are developing many relative policies as well. Let's look up a little specifically. The PV covered, and PV covered like over 30% until year of 2017. But we made an aim to increase our portion of the renewables like PV and wind until 2030 over 48.7 gigawatts. So that makes over 60%, 80% of the energy will be powered by PV and wind. We can see the left and below picture. There is a large scale of the PV will be, most of the PV plants will be covered by renewables, but it is very important to make an agreement for the people. So I chose two topics. The first thing is resident acceptance. This is a key factor to expansion of renewables in South Korea because we have very limited land scale. Even we have so many population, over 50 million, in such a small country. And as the renewable increasement, we need, there is an intermittent renewables. It is, in other words, it is very fluctuation of the renewable power because we cannot expect the exact power from the renewables because it is dependent on the weather like that. So we need a renewable management system for now on. So that those make the sustainable energy in Korea. So let's look up the RMS, which is renewable management system first. We in the International Energy Agency made 4 phases. The second phase is if the renewable sources is covered until the 15%, we call the second phase that phase we need a monitoring system. But after the renewable energy covers 20%, we need a controlling system because because the power grid system will be fluctuated by the renewables. So our South Korea is, like I see, South Korea is in the third phase because we need the RMS system. The first, there are three issues related to the power grid stability. The first issue is uncertainty of the variable renewable energies. So we need the local RMS power forecasting technology. And second issue is grid capacity surge. And third issue is we need monitoring and forecasting needed. The forecasting technology is very hard to make the goal because we cannot expect the exact weathering forecast because the PV power is dependent on the weather. So we need more specific monitoring technologies. So this picture is detailed RMS system. The left side, there is a PV or wind, like we call the VRE, variable renewable energy. We put the controlling terminal unit to the site, the plant site. Then we can generate the exact situation of the power plant, and also we can order to reduce or cut off the power generation for the safety of the grid system. So our institution is working on the investigate the real situation of the PV plant or wind plant to that they need the RTU for the controlling or not. So we have investigated many power plants in Jeollanam-do province, which has many PV plants in our country. Let's step up to the next theme. This is an agro-portable system. In Korea, we have limited land scale. So actually, there is except the urban cities, most of the land is farmland. But actually, we don't have enough land to build a PV system. So we have to think about the bifunctional system, like agriculture plus photovoltaic plant, so-called agro-photovoltaic. Because farmers are getting older and older, and the income and the salary is decreasing every year because of climate change. So we need a new strategy to grow the yield of the fruit or rices like crops make a shading by the PV module, and also we can earn more income for the farmers. Many countries are trying to demonstrate the agro-photovoltaic actually, and especially Japan has launched agro-photovoltaic system first in 2003. So and South Korea also are trying to demonstrate photovoltaic to various crops nowadays. So this is a basic system for the agro-photovoltaic system. Below, we are trying to try many crops because if the crop is shaded by the photovoltaic module, we can imagine the yield of the crops will be decreased dramatically, but the truth is not, because crop has every single crop have saturation point of the sunlight, because even the crops is shaded by the sun, but yield is not decreased dramatically. So we computer simulate for the build structure of, by the type of the module and distance of the module and also the structure.
3 minutes. Okay.
Okay, thank you. And there are some kind of many types of agro-photovoltaic PV system we are trying. And we have found 7 points to control to get more power and also to get more yield of the crops. So these are many demonstration sites in Korea. So our goal is the decreasement of the yield should be less than 20%. If we make a goal, then the income from the PV photovoltaic and income from the crops will be harmonized to get more salary for the farmers. This is a special and interesting picture because we had a big thunderstorm in 2019, so Ling typhoon. At that time, the crops was not dropped, fall compared to the open site because of the shaded effect. And also, the ovary was more healthy than the open site. So this is my conclusion. So as Dr. Kim, Professor Kim said, the average temperature, right? Average temperature 1.5 degrees Celsius was rising average, but in Korea, I saw the 1.8 degrees Celsius. So carbon neutral is essential for all nations, even in South Korea. So to expand renewables, people's acceptance is very important. So I think that we need strategies like agro-PV system and renewables management system like that. So this is my end of talk. Thank you very much.
Okay, thank you, Dr. Chang-Hun Kim. So we can understand the overview of green energy issue in Korea, including our province. Thank you very much. Thank you. Okay, so now our next speaker is from Cambodia. So I hope that our Zoom connection will work well. So Dr. Hak Mao is the Director of Department of Science, Ministry of Environment in Cambodia. Actually, he is the government official who is in charge of climate issue in Cambodia, and we have longer collaboration about citizen project. So, okay, now we can see you. Hello, Dr. Mao. Can you hear me?
Yes, I hear you, Professor.
Okay, thank you. So are you ready to give a talk?
Yeah.
Okay, please go ahead.
Okay, thank you very much, Professor, for introducing me to the events. And first, I would like to express my sincere thanks to Gwangju Institute of Science and Technology for inviting me to join 2001 Urban Environmental Accord YEOSU Summit. I'm going to share you the experience of climate change resilient development and adaptation in Cambodia. This is what I'm going to share you. I will share you briefly Cambodia climate change context, policy strategy response to climate change Cambodia, and I also give the example of a citizen technical assistance support project. First, let me share you information of climate change context in Cambodia. Cambodia is the most high vulnerable country to impact of the climate change. Especially we impact by flood, irregular rainfall, and coupled with agriculture-based economy, limited human and financial resources, insufficient physical infrastructures, and limited access to technologies. In order to respond to climate change, Cambodia is committed to combating climate change through joining international communities, events, and also other related activities. First, the country became a member of United Nations Framework Convention on Climate Change. We signed this in 1995 and became the members afterwards. And I will give some chronology of our activity with international community and even the activity in the country related to climate change. Cambodia has made substantial efforts to address climate change. And of course, we have adopted clear objective for the fight against climate change. And of course, the countries identify adaptation is one of our priority. Even of course, right now we try to balance between adaptation and mitigation. However, the countries, remain prioritized adaptation. On this, the country developed NAPA. This is one of the important documents of the country in 2006. As right now, NAPA still validated. And of course, only 2 projects that have been implemented, for NAPA follow-up. And of course, the country still need more resources in order to implement those proposed activities. I would like to inform that under our NAPA, we propose 39 activities. Besides that, the country developed National Financing Framework 2017. And then the country also developed national adaptation process and then a national adaptation communication strategies. This is the important document in order to support the country to implement climate change adaptation activities. Okay, here I'm going to share you some key milestones of our activities related to climate change internationally and nationally. As I said that in 1995, we signed the United Nations Framework Convention on Climate Change. And then in 2002, we became a member of Kyoto Protocol. And during that year, we submit our first national communication to the United Nations Framework Convention on Climate Change. And 2003, I didn't show here, but I just want to give brief information on that. In 2003, the country established Climate Change Office. This is the first time that we upgrade from the project-based climate change activity to institutional-based climate change activities. And then in 2009, the country established the Department of Climate Change that right now still exists. And in the same years, we integrate climate change into our national strategic development plan. It is very important step that we have tried to integrate our climate change into policy document. And more importantly, in 2013, the country developed the first 10-year climate change strategic plan, 2014 and 2023. And it is very important, our strategic document that still validated so far, until now. And of course, since now it's 2021, and since this target is expected to end 2023. So right now we in the brainstorm stage to develop the update our national strategic plan. We hope that maybe next year we will start the process. And 2014, of course, our climate change, we have integrate into the line industry. And of course, 14 line industry develop climate change strategies. And I think it is very important step that the line industry, they recognize that climate change is important, and then they even develop their respective strategies. 2015, I think 2015 is one of the recognized year for the world. First, as you may know, that Sustainable Development Goal also developed, and then Paris Climate Agreement also approved. During that year, you know, Cambodia submit our first national determined contribution, and also we submit our second national communication, and we also signed Paris Climate Agreement in 2016. We ratified the agreement. And you know, more important that in 2017, the country tried to integrate climate change into sub-national development planning process. I think it is very important for the country that climate change not only consider at the national level, but also integrate to sub-national level. And beside that, you know, we also integrate climate change into budget planning at a sub-national level. I think it's a very important step for our countries. And you know, having experienced this, you know, the sub-national authority right now, they become accredited entity to Green Climate Fund. So I think it is a very good progress for our country as well. Besides that, you know, 2018, climate change has been integrated into rectangular strategy. I would like to inform you that rectangular strategy is one of the important strategy of the government. After the national election, after the government formed, of course, the strategy is formulated. And so far, and during that time, you know, during the rectangular strategy 4, climate change has been integrated, especially in the pillar 4 called sustainable and inclusive development. So I think it makes our climate change activity more stronger, since it is included both under the government strategy and also under our national development plan. 2019, of course, 5 indicators on climate change sustainable development Sustainable Development Goal number 13 was aligned with our indicator of National Strategic Development Plan. And of course, during we also developing our draft environmental and natural resource code, and right now it's still under the process. And this code, you know, play very important for our country, and you know, to encourage and promote the sustainability of the natural resource management and also environmental management in the country. And 2020, of course, the country submit the first biennial update report, and also we submit our updated nationally determined contribution to the UNFCCC. And right now we're still under the process of preparing our third national communication. And also now the country preparing a long-term strategy for carbon neutrality, and we expect to finish and submit this strategy to the UNFCCC during the COP26 that's going to happen the next 2 months. Yeah, here I just would like to raise an example of our activity with the citizen. I would say that we have a lot of climate change adaptation project implemented in Cambodia. And I would say that we luckily that we get support from our development partners and donor country to implement climate change related projects. And of course, I would say that we really advance in terms of implementation of this climate change. And as I said, you know, we integrate into subnational level, and so far we become a accredited entity under the subnational authorities, and we try to mobilize resources from different partners and donors. And also we try to integrate climate change into our respective ministry strategy and plan. The reason that we want to do this because we want to ensure the sustainability of the country, meaning that even we finish, we don't have the support from the donor, but of course the climate change activity exists in the country. This is what we have tried to do right now for our country. And the TS support project from citizen. This project implemented by International Environmental Research Institute, and of course we have a very good operation, and Gangju Institute of Science and Technology. This project, of course, in cooperation with the Department of Climate Change of the General Secretariat of the National Council for Sustainable Development, Ministry of Environment. The name of the project we call the application of the gravity-driven membrane and technology for supplying sustainable drinking water to the rural community in Cambodia. And this project is expected for 1 year, and of course costs around 102,000 US dollar. And of course, this is expected to apply 3 community-scale GDM module for 450 people and 300 household GDM module for around 150 people. I would say that even it is a TA project, but the impact is quite very huge to our country, especially our country want to introduce the technology. Right now what we are doing right now, not only want to make the people access to water, but we also want to make the people access to clean water. So this project is really going in line with the government strategy, policy, and action in place. And of course, I also try to discuss with our partner that, okay, we need to consider the continuation of this project after this project end. And yes, of course, I think that maybe the opportunity will help in the future. Here, I want to share the objective of the project is to provide sustainable and safe drinking water to climate change vulnerable community in the rural Cambodia by using gravity-driven membrane water treatment system. I would say this is quite new for me personally, but of course, some of our colleagues also know this technology. But when we apply this technology, we feel that it's very important for our country context. The outcome of this project, we expect that the capacity enhancement of rural Cambodians to reduce safe drinking water scarcities associated human health effects caused by climate change. I think it's very important that we want to promote the human health. I think human health is very important. If our health is not good, we will have a problem. We don't have time to thinking about development. Promote and improve adaptive capacity of communities, especially through community-based adaptation. I think this is very important and also go in line with our policy and strategies. Community-based adaptation is very important in our country context, and also recently we also try to mobilize resources to implement this community-based adaptation in our countries. Expect impact of the project, it expect reduce risk of drinking water scarcity in the rural Cambodia caused by climate change and frequent drought condition. We hope that the project can provide the impact to our local community, even if it's a small project, but I think we can scale up. And also we will try to mobilize other resources in order to implement a similar project in the country. And I just want to show brief pictures of the location of the project. And we expect to implement in one of the provinces in Cambodia. And yes, of course, the team has already visited the location twice, and we hope that this is very fit with the country situation, especially the proposed location is really important, and of course, it really go in line with the activities of Ministry of Rural Development as well. So I would say that this project is very good for our country. So I would like to end my presentation and thank you very much for your kind attention.
Okay, thank you, Dr. Hak Mao. Okay, thank you. So we are collecting the question from the audience. So when we have all the questions, we will deliver this question to you to get your response. And here I have one announcement for speaker and audience. After we finish this session, we will take a group photo. So please stay connecting until we take a photo together. Okay. Okay. Now we have a next speaker, Professor Yoon Jin-ho at Gwangju Institute of Science and Technology. So his topic will be the increasing fire weather danger on the global warming. Hello, Professor Yoon. Okay, Professor Yoon, are you ready? Can you hear me? Professor Yoon. Hello? Hello?
여보세요? 지금 발표 끝나고 지금 목소리가 안 들렸어요.
Hello?
Okay.
Thank you, everyone. Well, first of all, I hope that you understand that even though I'm still in Gwangju, but I have to do this remotely. Thank you for your understanding. I'm going to give you some more like a scientific and technological stuff that we are doing as a climate science. I choose the topic that I'm also involved in much under some projects. That is that how the fire, what we call fire weathers, that can be increased due to global warming. And I believe that many of you heard that like this year, we have California fires, which is one of the biggest ever. And then in Turkey and Greece, there are a lot of fires just pumping up around the world. And when we talk about the fire, there are some issues that whether this is really due to a climate change or global warming, or there's can be associated with some a few people, someone's they just mishap like a light match and something like that. But the thing, what we are trying to tell you is what I'm trying to give you is that the ignition process, which can be due to human beings, which can be due to some natural process as like a dry lightning, but as long as there is the ignition, and then the fire can be grow or become a big and become threatened to human society, that means the fire has to be really grow a lot. And what we are trying to understand is under what conditions these can grow. And if you think about that, just without that much of the climate knowledge or the fire in general or the ecosystem, the thing is the trees has to be dry enough, and then and temperature has to be warm enough. There should be not much of the precipitation. These conditions, as long as these conditions can be set, and we have ignition, then that fire can go bigger and bigger, and so on like that. So this happens in early in February, which is usually we don't have fires in Korea, but this fire in Andong, city of Andong, that burns about 3 days, and it actually come down very close to the human population lives. But this is, compared to those fires in California or Turkey, this is, pretty small in terms of the intensity or the spatial scale. But still, the key is that it happens when usually it didn't happen in the past. And it happens that it grows bigger, and then it comes down to where the population lives. So we are trying to understand how much that this can be attributed, or this can be related or caused by the increasing temperatures. This is another example. Usually in Korea, fires usually happen along the East Coast region. And this is very due to a geographical reason that the winds blowing this way, then there's the wind blow down through the mountain ridge, and then it can be very dry and hot that bring to the fires typically. But what I just show you this year's case in February is right here. So usually people didn't worry much about in February, but now we need to think about that the fire season may be getting longer even in Korea, which is usually quite wet countries. Well, we have a lot of precipitation, but at southern seasons we do have fires, and then that can be big, and that cause problem. So the questions that we have been asking is, these fires, like those in California, those in Turkey and Greece, is it due to global warming? How much it can be attributed to that? And I think this the summit is also talk about the 1.5 degree warming, which is the IPCC report, and also after the Paris Agreement, that is there any benefit that we stop the warming at 1.5 instead of 2 degree? You know, can we quantify that how much we can actually have a benefit by stopping the warming at certain early level? So what we are doing is we are using this called fire weather index. This can be applied to any countries. This was developed in Canada, which is usually cold weathers and have a lot of forest fires. But we apply this to Korea, and then we've been applying to different regions, California and other regions. So this can be applied to anywhere around the globe to as long indicate that how well fire can grow. Okay. Once again, that we are not talking about ignition. Ignition, it can be different factors. But what we are assuming is without human being, there was still natural ignition process, like a dry lightning and so on like that. Of course, with human being, like in case of Korea, all the fires are related to the human mishap, like a matching and then the burning, intentional burning and so on. But the key is, as long as we have ignition, how much it can grow, under what condition it can grow. And the key variables are temperatures, how humidity, and wind and rain. And there's some complex interaction, but we can make that some simple index. It just give us a number at one locations at certain time, and we can see how that changes under different scenarios of the climate change. Once again, FWI is only function of weather and climate. It doesn't nothing to do with the ignition process. So the good, that's why that it can be easily computed at station data or the grid data and so on like that. And then in here we are using this called the experiment called HAPPY. This is a half a degree additional warming prognosis and projected impact project. So what we are trying to understand is the difference between 1.5 and 2 degree. If we stop the warming at 1.5, how much benefit we can get, and so on like that. The HAPPY is also providing a really many ensemble, meaning that just many realizations. So the reason that the climate scientists are sticking with this large number is we have more samples, then we have a high confidence in our result that this can go one way or the other. And this is why that we are using this type of experiments, but the purpose is we are trying to look at the impact due to the warming. So we call this as an impact driver. So for example, like a landslide is not just happening due to the soil is loose and so on. They're very highly likely that there has to have a heavy rain that comes down to the landslide. But in case of the fire, it has to have the dry, it has the drought, not just only short period, the long period, and then the wood has to be dried up quite a bit so that fire can go easily and so on like that. So to look at these impact drivers, that the large number of realization is quite useful. And this is still talking about two different approaches. Typically, what we are doing is the top panel. When you say that when you are talking about IPCC report, that's the top report, the top portion. As the year progress, how much greenhouse gases we emit, how much impact that we will have. But the HAPPY approach is a slight difference. This HAPPY is just, as I said, is just right after the Paris Agreement that goal is the 2 degree, but hopefully we can stop at 1.5. That the question is there that 0.5 degree warming is really important? And as you might guess, my answer is yes, it is important that if we stop that 1.5 degree, we can reduce the really the extreme fire weather dangers, meaning that those fires can grow bigger than even the city of Gwangju and so on. So this is a graph is quite busy, but I can show you that the top figure, that this one is that we compare with the current days, well, without warming scenario, and then if there's a 1.5 warming scenario. And the bottom one is the same thing, but with the 2.0. What we see right away is that, oh yeah, the color becomes a more reddish colors, meaning that comparing just this extreme fire weather dangers, that the 1.5 degree and 2 degree there's a clear differences. And to see this more drastically, we're plotting this the probability plot. But as you can see that the history and the 1.5 and 2.0 degree, this is not like a linear increasing. This extreme danger is increasing as like a nonlinear functions. So if we stop at the 1.5, there's certainly clear benefit. And the benefit can be bigger at certain location. For example, like the California regions, the benefit is quite big, or the Southern Africa is big. But in terms of Australia, it doesn't show up that much, at least in the exercise. And then this figure is showing you even more drastic differences. We are picking up, for example, like these boxes, we are picking up the biggest fire season. So for example, in Asia, it's usually in winter time, like in Korea, but in the tropical countries, it's usually in the fall, September to November. If we look at this, the difference is much clearer that when we have a big fire seasons, we can at least mitigate some risk of getting huge fires. And then it's more like the next question you might have is something like this. Well, I see that the fire weather danger has been increasing due to the warming, and then there might be the benefit really due to stop the warming at certain degree. But then those differences are really due to just the increasing temperature, or there's some random phenomena of the weather and so on like that. So what we are showing you here is at different locations, which variable, this is the temperature, this is wind, this is a moist variable. So for example, what we are showing you in Korea, for example, Korea's case or the California's case, the key driver making that increasing fire danger or the limiting the fire weather danger is temperature. But in tropical countries, it's more complicated. It's not the temperatures that drives the fire weather danger. It's more toward the precipitation or the humidity. So there's a very clear difference between the tropical countries and the middle latitude countries, that the driving the fire weather is in middle latitude is easily just temperature. So as long as we can stop the warming at certain level, we have a benefit, and then we see that signal clearly. But in tropical countries, this is more complex, that it's not just only temperature, but the moist variables function as a more important. So this is just a difference between the temperatures at the 1.5, 2 degree, and then 2 degree and the 1.5 degree. You see that 2 degree and the 1.5 degree. In terms of the global warming, this is only half degree. But if you look at the regional differences, it can be a lot bigger than half degree. So once again, what I'm trying to tell you is that the half degree warming seems nothing, because we already have like around one degree warming since the Industrial Revolution. But additional half degree, meaning that we can really reduce some dangers due to the environmental disasters. This is the humidity and rains, but then see in terms of when you come down to the precipitation or the humidity variable, the biggest change is along the tropical countries. But temperature is overall globe and is even higher in the middle latitude regions. In terms of the wind, we didn't see much of the differences. But so the wind changes is, we regard it as a kind of minor processes in determining this the fire weather dangers. So here is my conclusion that what we are trying to do is so-called the climatic drivers. How much the climate drive the fire weather dangers. Like this year, we have a lot of fires, big fires, and people have been killed. And then, for example, in California's case, the electricity company PG&E filed the bankruptcy to compensate the people who were killed by the fires. So relatively in Korea, this is not like a major issues, but in terms of the other countries, California, and then like Turkey, the Mediterranean countries, the fire weather becoming one of the key issues in the next decades and so on. And then based on our result, there's a very clear benefit. We stop the warming at 1.5 rather than 2 degrees. And we see that these impact drivers, that we can clarify that this is really due to temperatures and so on like that. So that's all I have today. And once again, thank you for your understanding that I present this remotely. And if you have any questions, you can send me email or chat and so on like that. Thank you very much.
Okay, thank you, Professor Yoon. So thank you for your interesting talk with the warning from the global warming. So now we can move to the last speaker. The speaker is Clara Landeiro from Asia Pacific Manager. She is Asia Pacific Manager at Climate Technology Center and Network. And Clara will summarize the supporting innovation climate technology for the case in CTC and technical assistance. Clara, can you hear me? Hello?
Yes. Yes.
Yes, so
I was trying to unmute myself.
You have
Yeah, thank you very
15
much.
minutes, so I will give you sign when 3 minutes left. Okay?
Okay, and
please
I
go
can
ahead.
now start the presentation. I have the controls, correct? Let me check. Oh, sorry. Yes. Yeah, sorry for this mishap. Hi, everyone. Good afternoon. And good morning and good evening for those that cannot join us in presence where you are. Thank you for your introduction. I'm Clara Landeiro, Asia Pacific Regional Manager for the Climate Technology Center and Network. And it's a pleasure to be here with you today, though remotely, unfortunately. But I would really like to congratulate Mayor of YEOSU, Mr. Oh Bong-kon, for hosting this important summit of urban environmental accords in his city. And let me also take the opportunity to acknowledge and thank the government of Korea for their leadership, support, and continued collaboration with the Climate Technology Center and Network, for short CTCN, I'll be referring to as the acronym, to develop and scale up climate technologies, in particular in Southeast Asia, and for their support to the soon to be established CTCN Partnership Office, Liaison Office in Songdo in Korea, which we think it will play a major role in research and development of transformational climate technologies. So finally, and before I start the presentation, I would like to thank the organizers, and in particular the Gwangju Institute of Science and Technology, for their kind of invitation for me to participate in this discussion with you today. GIST has asked me, the organizers have asked me to share some of the work CTCN is undertaking to support innovative climate technologies that foster adaptation, including a program launched less than a year ago and now under implementation, which is the Adaptation Fund Climate Innovation Accelerator, known as APSIA program. Since the APSIA program is fairly recent, with no projects yet under implementation, we thought of sharing with you first some examples from past and ongoing implementation of CTCN technical assistance in the Asia Pacific, focusing on Southeast Asia, to show you the diversity of adaptation initiatives that developing countries in the region are undertaking, leveraging technology to meet their NDC targets and strengthen their climate change responses. In doing so, we would like to zero in on one particular case. Sorry, I didn't put the, yes. So in doing so, we would like to zero in on one particular case, the CTCN technical assistance support to Laos. And then finally also present to you more as an opportunity for you to explore the APSIA program. Before I start, and for those of you that are probably not as familiar with sorry, this is going too fast, with CTCN work and the entity itself, I would like to tell you a bit about us. So the CTCN is the implementation arm of UNFCCC mechanism, technology mechanism, and is hosted by two agencies, the UNEP, the United Nations Environmental Programme, and the United Nations Industrial Development Organization, UNIDO. It has been mandated, CTCN, by COP to promote accelerated development and transfer of climate technologies for energy efficient, low carbon and climate resilient development at the request of developing countries. Leveraging the expertise of these two hosting institutions, UNEP and UNIDO, as well as a global network of 600 partners, including private sector entities, civil society, research institutions. CTCN facilitates the transfer of technologies to the three core services: providing technical assistance at the request of developing countries to accelerate the transfer of climate technologies, creating access to information and knowledge on these technologies, and fostering collaboration among climate technology stakeholders via the center's network of regional and sectoral experts from academia, private sector, civil society, and public and research institutions. Maybe I'll stick to the cursors. CTCN has a number of ongoing initiatives to promote collaboration, capacity building, and knowledge sharing and network engagement. Our core technical assistance by far constitutes the largest share of CTCN services. About 70% of our core services are technical assistance related. With over 100 countries now having received or are receiving still CTCN technical assistance, over 300 technology transfer initiatives since CTCN was created in 2014, and with 30%, about a bit more, of these technical assistance requests coming from Asia Pacific. A quick look. A quick look at the technical assistance portfolio gives you an idea of the global demand for technical assistance support. We can see this is a global picture. We can see that the graph on the left, that still mitigation is where most of the technical assistance requests come from, although this picture is changing currently with almost we got to parity almost this year in terms of the number of technical assistance requests, adaptation versus mitigation. As to the type of requests, we can see that there has been a high demand. This is on the right. We can see there has been the highest demand is it's on information monitoring and decision support systems. So building into the knowledge base on climate change adaptation and mitigation is really the highest demand, but also piloting and deployment of technology options and feasibility studies. Those are the highest, where the demand is most clearly the highest. A look at the sectors where, just looking at the adaptation related technical assistance requests per sector, agriculture and water, as well as early warning system and coastal zones are also where demand is more pressing, as far as we can see. Finally, a bit about the process. How do we, what's the modality for CTCA providing developing countries with technical assistance support? As mandated by COP, CTCN delivers technical assistance always at the request of developing countries through their national designated entities, or NDEs. Interested parties, and can be of many origins, private sector, NGOs, etc., but also ministries and government entities in developing countries contact their national focal points, their NDE, to request technical assistance. Then, in a second step, the NDE confirms the alignment and endorses or not the request for technical assistance. And then in a later phase, CTCN collaborates both with NDE and the project proponent or the applicant to develop a tailored technology transfer plan, which we call response plan. The CTCN then, through a robust procurement process, selects one CTCN network member to implement the technology solution in the country. This CTCN network, so our network of technology service providers is growing fast. It now counts with 650 network members around the world with a wide range of expertise and experience, both in terms of the range of sectors they cover and the regions, the experience in the regions they cover as well. The majority of our network members comes, about 50% or so, from private sector technology companies, but with a significant number of research and academic institutions. And these are the entities that really provide the support on the ground to help implement the technology solutions. So let me share with you, So after this brief overview, let me share with you some experiences from CTCN support in Asia Pacific region, in particular in Southeast Asia. And this technical assistance is helping to address challenges in different adaptation related sectors. I try to bring here those that most relate to the audience: infrastructure and urban planning sector, early warning and coastal zones, and water management. In the interest of time, maybe I will reduce a bit the number and you'll stay with the slides for your perusal. And also these are links to our website where you find really more detailed information about the project, their deliverable, and the impacts they're having. Both TAs, both technical assistants on this slide highlight the work of Sri Lanka and Indonesia, but they show two slight different modalities of CTCN technical assistance. The development of Kurunegala as a smart city is a project, a CTCN technical assistance project, fairly recent, 2020 and 2021. It has been implemented with Korea Pro Bono support through ECHO Network. Network member. In Indonesia, one of the earliest CTCN technical assistance on hydrodynamic modeling for flood reduction and climate resilient infrastructure development pathways in Jakarta. This helped, this is one of the earliest technical assistance that was implemented with the support of UNEP DHI, one of our consortium partners. And this has helped Jakarta in addressing urban flood issues and support also sustainable city planning in Jakarta. The results of these projects are long-lasting, and they keep assisting the urban planners in their decision-making and in addressing the multiple challenges they have in their cities posed by climate change. This is another example on the water sector. I won't detain here. Suffice to say, Dr. Mao already went in depth with the project, the second project that you see on screen there, on the gravity-driven membrane technology, which is it is a project that's still ongoing. It's not finished with Korea pro bono support, implemented by our host GIST, and it's currently it's being successful. I just brought it in because I think it's good to emphasize that this project illustrates the great potential for replication and scale up of this technology to other areas, not only in Cambodia, but around the region and beyond. So now,
Clara, 3 minutes left.
Yes, yes.
Thank you.
Sorry?
3
Again?
minutes left. 3 minutes.
3 minutes
Yeah.
left.
Okay.
Okay, so let's, I took a little longer than I wanted, but let me just then tell you about the work in Laos, and apologizing to Laos for the bad work I'm doing in rushing through a very good example of this TA. So let me just go to the last slide here. Oh, these are passing very slow, or is it just my screen? Okay. This is another project we have in Laos, but I go to the summary of this one and ask the audience if they're interested to really go into our website and find out the details. The work in Laos started with technical assistance from CTCN on the city climate vulnerability assessment and identification of ecosystem-based adaptation interventions in Laos. And it really delivered climate vulnerability assessments for 6 cities, identified technical options for ecosystem-based adaptation interventions, and resulted also in a draft GCF funding proposal. Now, we had a follow-up of that, a very short-term project. We call it fast technical assistance for designing, for really addressing those further economic and engineering analysis that were needed to really strengthen the proposal for GCF, and really it culminated in a successful GCF funding proposal, which is now, the project is now being implemented. The other project that I didn't have, I just leave it as a slide that passed. The Jeff Challenge program is something that will probably interest most of you. It's an upcoming program, a multi-country program with Laos, one city in Laos that will implement, it will pilot this program. It's piloting innovative financing for medium-sized cities. And I leave it because I know many of you work at the city level and are interested in climate resilience, but also how to roll out that implementation, and access to financing is always a must. So here I just leave you. We think that this support and the work together with the Lao NDE and the work also with the DNA in Laos, the adaptation focal points, the national focal points, has been really transformational. It has helped from the 6 initial vulnerability assessments of the 6 towns. There are today 145 vulnerability assessments, with the National Vulnerability Assessment Report endorsed this year by the government. It, from a total cost of those 2 initial, the TA and the FTA, of $270,000 investment, let's say, the country was able to leverage over $10 million, the US dollars, through the GCF. And I'm sure it will serve. And this is all because they invested in strengthening the knowledge base. And so that has enabled Laos now to get very strong proposals that can be financed by financing mechanisms. Just last but not least, just to flag you an opportunity, which is the Adaptation Fund Climate Innovation Accelerator. This is a program that was launched last year, end of last year, 5-year, 10 million grant from Adaptation Fund with administered by two agencies, UNEP CTCN and UNDP. They really have two different modalities. 5 million each was the adaptation fund split up for these two agencies. For the UNEP CTCN, it is about providing technical assistance, always with CTCN. So this is to support developing countries to test, evaluate, roll out, and scale up innovative adaptation practices, products, and technologies. With a budget of 5 million from an adaptation fund, plus 1 million co-financing by CTCN sources, we expect to implement 25 technical assistance projects up to $250,000 US dollars each per project. So there is here the link to access. There is a lot of resources online, but just to give you a really quick look on who can apply is developing countries. Only those without national implementing entities, only those that do not have entities that can direct access adaptation funds. And priority is given to LDCs and SIDS. Applicants can come from, can be many entities, both government, non-government, young innovators. So we kind of challenge you to look into this as an opportunity to really invest and get the work rolling in your cities, in your geographies. Applications need to be, and we really do recommend and that you start early to work with the national focal points. Both these proposals need endorsement both by Adaptation Fund designated authority as well as the CTCN national designated entity, so that they can ensure alignment with national climate adaptation priorities. But it is an opportunity, I think, not to be missed. Right now, there has been already 2 calls this year, and we had after screening, we have 189 applications, almost 200 applications so far, with over half of them from LDC and SIDS. In the region, there's very number, as you see the size, the total size for the 5-year program is 25 technical assistants. Right now, we have only in each round, we select very few in the region, and this is a global program. In the region, Maldives, Nepal, and Vietnam are in different stages of processing. Nothing has been implemented yet. We're still on the procurement stage, different stages of development, but we expect and we ask for those interested that you check it out and that you apply. We really, and Adaptation Fund, both with CTCN and UNEP, we really want to encourage, and we're having a lot of other innovation-related initiatives to see if we can get really good, impactful adaptation solutions, technology solutions on the ground in the region and in overall. So we can see that still from the applications received, the major adaptation sectors are agriculture, rural development, food security, and water. So the food and water nexus is very much present there still on the technology requests that we received in these applications, 2 rounds of applications for APSID. But in conclusion, really, is we can see that there is still a large appetite and need for adaptation-related technical support in developing countries. And that we also see by working with the countries in developing these proposals that we see that there's still a lot of support needed from developing countries in identifying and articulating their adaptation technology demands. And this is particularly true for LDCs and SIDs. So finally, just to leave you a challenge to explore opportunities and contact us, please feel free to contact us. You can access directly the AFSIA through this link, and in the website you will find many publications, many tools, over 17,000 publications on technologies, on case studies, etc., that we encourage you, and including those that are about the projects that I've selected to highlight in this presentation. So I hope I didn't exceed the time, and thank you very much. Back to you.
Okay, thank you, Clara. So thank you for your interesting talk. So now we will close the session, but before we close the session, we would like to have a group photo together. So please stay connecting. Then our speakers and audience, please come to the stage. Then we will take a group photo. Then we can go home, okay?